Okay, so as you can see here, we have been given a task to graph the line 2x plus 3y equals 12. Now it already says that it's a line, and that's awfully convenient because if it just said graph 2x plus 3y equals 12, just by looking at the equation, it might be difficult to determine what this might even look like on a Cartesian grid. Thinking back to linear versus non-linear, it's sometimes good to already be able to look at the equation and know whether something is going to be linear or non-linear. Now back once upon a time when we were talking about linear and non-linear, the whole thing came down to if you can look at an equation and look at the variables and they are all to the exponent of 1, we can say for certain that it's going to be linear. So it is nice that they said graph the line 2x plus 3y equals 12, but if they didn't, we would still be able to figure out that this is going to be linear. So in graphing something that is linear, it's nice to know that it's going to be a line, but boy, there's a lot of different lines that you could put on a Cartesian grid. So how exactly does this line look? We're going to go through 3 options today, and not all of them are going to be equally good. So in graphing a line, 2x plus 3y equals 12, here's option number 1. Calculate some ordered pairs. Now don't forget, ordered pairs are the x's and y's that are in a table. And if we had a whole bunch of x and y ordered pairs, we could certainly plot those on a grid and see what 2x plus 3y equals 12 looks like. Well, let's just entertain that for a quick moment. So the equation again was 2x plus 3y equals 12. In determining ordered pairs that belong to this equation, a lot of times it's confusing how to even start. Well, there's no real sound strategy other than you want to choose a value for x or for y, plug it into the equation, and solve for the other variable. So showing how that works for just one ordered pair, I'm going to think of my favorite number. My favorite number is 5. So I'm going to plug 5 in for x and determine what is the value of y when x is 5. Well, I go over to the equation and I replace x with 5. And I solve this equation for y. Well, 2 times 5 is 10, plus 3y equals 12. Now, thinking about my equation solving skills, I'm going to subtract 10 from each side. And now I have 3y equals 2. And then I divide both sides by 3. And I get y equals 2/3. For the purposes of this table, it might be more convenient to change it to its decimal approximation. And rounding to the nearest tenth, 2/3 is about 0.7. So I can put 0.7 in this table. And I can repeat this process, just choosing numbers and replacing them with x or y and getting a whole bunch of different ordered pairs all the way down this table. Well, as you just saw, it's a lot of work to just get one single ordered pair, let alone a whole bunch of them, so that you could plot them on a grid to see the line 2x plus 3y equals 12. This option of just calculating some ordered pairs, while it does work, it is a really lousy option. Yuck. Okay, this is not a good way to graph this line. So let's go on to option number 2. Option 2 is better. It's considerably better. It says here, determine the x and y intercept. So, I need to back up a little bit. When the equation of a line is written in this form, okay, where you have x and y on one side of the equal sign and then some constant or number on the other side, this is often what's called intercepts form. Intercepts form. And it's given that name because when the equation of a line is written like this, it is pretty convenient, not that hard at all, to determine the x-intercept and the y-intercept of the line. And if you think about it, the x-intercept and the y-intercept are dots that we can place on the Cartesian grid. Somewhere along the x-axis is the x-intercept, and somewhere along the y-axis is the y-intercept. And if we can plot those two dots and we know it's a line, then we know we can make the line with just two dots. So we don't need a whole bunch of dots, really. We just need two dots, and the x and y intercept are two dots we should be able to figure out pretty easily. So here goes. We're going to, first off, write the equation down. It's 2x plus 3y equals 12. And now we have to think about the x-intercept and the y-intercept a little bit. So let's talk about the thing that's more familiar to us, the y-intercept. The y-intercept we know is a dot that falls somewhere on the y-axis. Now, I'm just going to go ahead and put a dot right here. Now, I have no idea if the y-intercept for this line actually belongs there, but I'm just putting it on there to, I guess, get us thinking about the ordered pair. So the ordered pair for this dot is clearly 0, -3. Fine. Now, what about this dot right here? Well, that's 0, 6. And you know what? I can continue placing a whole bunch of dots anywhere along the y-axis. And what do they all have in common? Their ordered pair. What do they all have in common? They all have an x value of 0. And that's true for any y-intercept. I'm going to repeat that. For any y-intercept, the x value is always going to be 0. So if I want to determine the y-intercept of this line, I'm going to replace x with 0. And when I solve for y, that will be the y-intercept. So in a similar way to the previous slide where we replace x with a value and solve for y, we're doing that again. But look at this. When we replace x with 0, that leads to much simpler math. 2 times 0 is 0, plus 3y equals 12. Writing the left side just a little bit simpler, it's just 3y equals 12. And there's really only one step we have to do in solving this equation. We get y equals 4. Y equals 4 means that the y-intercept for this line is 4. I can place a dot right there. The y-intercept is 4. Half of my work is done. The only other thing I have to do now is determine the x-intercept. Well, when we think about the x-intercept, and I get it, we're less familiar with x-intercept. But x-intercept is a dot somewhere along this axis for the line. And if I place just a couple of dots here, so let me place a dot, I don't know, right here. Maybe the x-intercept is right here. And if it was, the ordered pair would be 6, 0. But maybe it's not there. Maybe it's actually over here. Well, what's this order pair? It's -5, 0. So this now makes you think about all of the dots that belong or that would end up along this axis. What do they all have in common? Their ordered pair, the y, is always 0. The y is always 0. And so what we're going to do now is use that to our advantage and replace y with 0 in our equation and solve for x. When we do that, we will have determined the x-intercept. Let me get rid of this stuff off of the grid because we are solving for x. So 2x, 3 times 0 is 0. Equals 12. Again, simplifying the left side, we quickly realize that, wow, another very easy to solve equation. And we've got that x is 6. What does that mean? That means that the x-intercept is at 6. And when you look at this line and realize that we now have the x-intercept and the y-intercept, it's pretty easy to see that I can make a line. That was not the line I wanted. Let me undo. I was trying to choose a line, a straight line. Oh, that's not working again. Bear with me just a moment here. Last chance. Make a line. Ah, that's what I'm talking about. And there's no need to just leave it as a little line segment. I can certainly extend this line beyond just the x-intercept and y-intercept. So it's a nice, much longer looking line. So there it is. There's a line 2x plus 3y equals 12. And this option was way better than option 1. So option 1, no good. Option 2, way better. In fact, I'm going to put a green check mark saying I like that. And this will work for any line as long as it's written in intercepts form. What's intercepts form? The x and y variables are on the same side of the equation, and then there's just some constant or number on the other side. I am going to show you one more option for how to graph a line when it's not in slope y-intercept form like this one. It's to manipulate it into y equals mx plus b. What the heck does that mean? Well, what it means is that we are going to take this equation, which we will know is not in slope y-intercept form because we're really good at slope y-intercept form now. We've seen it a lot, we've used it a lot, and we should have a very good recognition at this point to look at an equation and make the basic decision. Is it in slope y-intercept form or isn't it? This one is most certainly not. So we're actually going to do some work to get it into slope y-intercept form. And then once we have it in slope y-intercept form, that's very easy to graph. In fact, we were just doing that just a short time ago. So here we go. We're going to try to make this equation look like slope y-intercept form by the time we're done. So I'm just kind of putting this down at the bottom, almost like the finish line. So the starting line is where we are right now. We're trying to get to the finish line, which is to have it looking like slope y-intercept form. So as I look at this equation and I think about manipulating it, that basically means using equation solving steps to transform or to change or to manipulate the equation. And what I'm thinking is I'm going to subtract 2x from both sides. This might seem a little strange if you're at all confused about what's happening. But hopefully it'll start looking like something here in just a short bit of time. When I simplify the left-hand side, I end up with just 3y. And when I simplify the right-hand side, and I'm going to do this on purpose, I'm going to put the negative 2x first and the positive 12 after. Why am I doing that? Well, because I'm thinking about the finish line. I'm thinking about my finished product. And slope y-intercept form often has the mx coming before the b. So like the x part, I'm going to go ahead and put it right away, kind of where it's going to end up wanting to be located so that it looks like slope y-intercept form. The next step is to get rid of this 3 from the left-hand side so that the y is isolated, so that it's all by itself. So I'm going to divide this side by 3, and I'm going to divide this side by 3. Now that's going to be a little weird, but follow along here. The left-hand side, easy peasy. That's just y equals, just like we want it to be. The right-hand side is kind of a mess right now. But here's what we're going to do. We are going to take this, I guess, combined fraction and separate it into two different fractions. And yes, this works all the time. I know you were asking just now. So yes, you can do this all the time. Separate it into two fractions, and then the final step is to simplify each part. So negative 2/3 x, like this, and 4. Notice that suddenly this looks like slope y-intercept form, where the slope is negative 2/3 and the y-intercept is 4. And now when I go to graph this line, I plot the y-intercept, positive 4, and then I use the slope, negative 2/3, to go down 2 and to the right 3 to make another dot, and I repeat that process, down 2 and to the right 3, down 2 and to the right 3. And if I want to reverse the process, I can go to that y-intercept and go up 2 and to the left 3. And I'll do that just once more. I've got a whole bunch of dots now, such that I can, with very good precision, graph the line y equals negative 2/3 x plus 4, otherwise known as the line 2x plus 3y equals 12. So here's a quick review of what we've done. Back to the first slide. We were given the task to graph the line y equals, graph the line 2x plus 3y equals 12. The first strategy, calculate some ordered pairs. This is tedious and difficult, and there's just a better way. Although it works, there's a better way. Here's a better way. Determine the x-intercept and y-intercept. So we're specifically targeting 2 dots on this grid that we can easily figure out. And once we place those 2 dots on the grid, we can make our line. This was a very good option. And here's also a good option, which is to take the line and get it in the slope y-intercept form so that we can then graph it. I'm trying to find some green ink. This is also a good method. Out of these 3 methods, which one is your favorite?